All right, so let's go ahead and take a look at this part here. All right, so when we talk about this, we're going to talk about determining whether each function is continuous at the given value of x. So we're going to follow those steps, the 3 steps that we just wrote down on the last video, and we're going to go through those and we're going to determine whether these functions that we have is continuous or not. So we're going to have 3 of them, a, b, and c, and we're going to talk about it and figure out if we're continuous or not. So let's go and start with a. So first off, we said the first step is f of c must exist. If you look at this part here, x equals c is x equals 1. So c is 1 for this problem. So here, we'll do f of 1, and we're going to substitute it into the function here. If it exists, that means step 1 is satisfied. And we move on to step 2. If step 1 is not satisfied, then we just stop and be like, oh, can't do this. All right, so 1 squared is 1, and then 3 plus 7 is 10. So step 1 is satisfied. We have a number. We have a numerical value. Cool, we're good. All right, so let's go to step 2. Step 2, we will be using tables. And we said here, we need to look at as limit as x approaches c. And in this case, c is 1. In this case, c is 1 from the left side of the function. And we'll also take a look at it as it goes from the right side. So again, this is talking about our left side of the graph. Oh, let's change colors. This is our left side of the graph. This is our right side. All right. Now, with this, before we actually move into like in-depth stuff, we have to kind of figure out what's going on with our x values, because we have to fill in our table here and talk about what's going on there. So we're going to do f. We're going to do x here and f of x here. All right. So with this, before we actually try to figure out what's going on in the table, we have to go back to like what we're talking about. And I need to fix this part right here because it is 1 with that plus sign, which means from the right side. So let's go ahead and look at our number line really quick. Look at our number line. We know 1 would be right here. Out the way. 1 would be right there. If we're talking about from the left side of the graph, the left side of that, we know on the left side we have 0. We have 0.5. We have 0.8, we have 0.9. But as we get closer and closer to 1, we're trying to get as small as possible or as closest to 1 as possible. So here, what we can do is we can do 99.99. We can do 0.999. And also here we can do 0.9999. And so all those, as you can see, is getting closer and closer to 1, but hasn't touched it yet. Like it rounds up to 1, but we haven't really gotten there yet. So what we're going to do, and I think we have enough space for all of those, 0.9, do 0.99, 0.999, then 0.9999. I'm going to put the zeros here too. So 9/10, 99 hundredths, so on and so forth, 99 thousandths. All right, so with that, we're going to put that into the calculator and we're going to find out what the value is. But before we do that, let's go ahead and figure out what the right side of the table is going to look, or how it's going to look. So on the right side here, we're coming to 0 from the right side. You know, we start off with like 2, so it'd be like 6, 7, 8, 6, 5, 4, 3, 2. Then we'll have like 1.5. Then we'll have like 1.1. And as we get closer, 1.01, 1.001, and everything's starting to mush up there. Sorry about that, guys. Let's see, 1.001, and then another one, 1.0001. And as we're getting closer and closer to 1, we're getting smaller and smaller. All right, so with that, we're going to use that in here. And I apologize, that looks like really crazy and small. So we'll start off with 1.1. We'll do 1.01, 1.001, and then 1.0001. We're going to put this into the calculator, and we're going to determine what is the value for it. What are our values? So let me go and turn off my marker here for that. And let's go ahead and pull you off. Right. And let's go ahead and put my calculator up because I need that. There we go. All right. So with our calculator, we're going to go and put these values in. And we're going to we've already done this like in class. So we put the function 3x squared, which is right here. So the 3x squared plus 7, put that into the calculator. We go to second window, yeah. And we come down here and make sure our independent's on ask. And then we go second graph. And we put have the table here. So with that, we've already done the 1.01, the 1.1, 1.01, 1.001, 1.0001. So we're going to put those values in the table really quick because we've already done it. And then we're going to put in the 0.9 into it also. That'll be our next thing. All right, so we have those going in. And we'll talk about what that means or what it's saying in a few seconds as what x is approaching. All right, so with the other part, let's go ahead and put in 0.9, 0.99, 0.999, 0.9999. All right, so here we're going to put in, let's put in red, 9.43, 9.9403, 9.994, and then 9.9994. So as we're looking at these, and we have to, again, kind of tell what's happening. So as we're looking at this, as x gets closer to 1, your y value is getting closer and closer to 10. Because 9.9994, if we go again, it's probably going to round up to 10, or it's going to be like 9.99999, or something of that sort. So it's going to 10. For the right side, as x approaches 1 from the right, our values here are getting closer and closer to, again, 10. So just doing our limits really quick. So limit as x approaches 1 from the left side of the function, we get 10. And then as it comes from the right side, remember that's just 1 with a plus sign there, we get 10. So as it goes from the right side and from the left side, we get 10. So our whole goal is to get them to equal each other. So that is what is happening here. As x approaches 1 from the left equals the limit as it approaches from the right. So that means we satisfied step 2. And so in other words here, just really quickly, this is 10 equals 10. All right, so we satisfied that. Woo! All right, so now the last part is step 3. All right, so step 3, we said that step 1 must equal the value in step 2. So the value in step 1 was 10. And again, going back to that really quick, the value here at step 1 was 10. The value at step 2, again, was 10. So therefore, this function is continuous how do I say it? That's it. This function is continuous at x equals 1. Now, one thing that when you get to calculus and everything, you start looking at those pieces, it will say, okay, using the definition of continuity, this function is continuous. Using the definition at x equals blah, blah. Using the definition of derivative, definition of continuity, this function is not continuous, blah, blah, blah. And so they'll be expecting those parts there. But we're not going to do that here because we didn't really call this a definition of continuity, but it really is a definition of continuity. So that's pretty much it. That's how it is. That's how we're going to flow. So again, this function is continuous at x equals 1.